So the binomial theorem deals with what happens when we expand a binomial or we FOIL it out. Binomial having two terms, those are all these guys on the left here. And we can FOIL it out, multiply it out, combine like terms and so on, but we can have a more efficient way of dealing with it. If we take a look at the pattern, and a plus b to the 0 is not a good way to start, but a plus b to the 1, notice that the exponents on a and b are both 1. A plus b to the 2, we've got a squared and b squared on the outsides, and so on and so on. Those exponents continue on. So if we consider that we have a plus b to the n in general, then the first observation we can make is that the first term is always a to the n, and the last one is always b to the n. As for the number of terms, if we just start counting, well, if we go a plus b to the 5th, we have 1, 2, 3, 4, 5, 6, then 5, 4, 3, 2, down to 1. So there's always going to be n plus 1 terms. The exponents of a, well, we always start off at a to the n. As we go through each expansion, we would have a cubed here, we have a squared, a, and then we have no a's, which would technically be a to the 0. Likewise, the exponents of b, they do just the opposite thing. We started off with b to the 0, all the way up through b to the n. And the last observation for now is that the sum of the exponents of any term, so let's just pick 10a squared b cubed, 2 plus 3 would be 5, that always adds back to the original exponent n. We haven't talked about the coefficients yet. That would be such as the 4, 6, 4. We also have 1 coefficients here that aren't shown, but they are there. We're going to talk about those in a couple of minutes.